Hello everyone, welcome back again. In the last video, I talked about how collaboration may help students explain visuals, because when students explain to each other how visuals show information, they're much more actively engaged than when I give them, say, a bunch of fill-in-the-gap sentences that prompt them to explain this to themselves. And in fact, you may remember in some of my past videos that I showed that students actually benefit from support that helps them collaboratively explain visuals. But still, there are many open questions about how best to help students explain visuals to one another. So in a recent experiment, my student Sally Wu and I investigated this question in a study that was part of a chemistry course where students collaborate on chemistry problems that ask them to translate 3D ball and stick models into 2D visuals. So we tried two approaches. One approach was to ask students to first plan the 2D visuals on paper before they would then put in their 2D models into the computer where they would get immediate feedback. And then, if the students made a mistake in their 2D drawings, the computer would give them feedback that would ask them to fix the mistake together with their partner, while again, first trying it out on paper. And I should add that this is the strategy that the teaching assistants in this course typically took, because they think it's easier to plan this relatively complex 3D to 2D translation on paper first. So the second approach was to ask students to directly translate from the 3D model into the computer-based 2D drawing without trying it out on paper first. And then if they made a mistake, the computer would prompt them to work with their partner by holding up the 3D model against the computer to fix their 2D drawing in the computer. And then a third group worked without computer support on the same problem, so that means they did the business as usual way to just draw on paper, hand in their answers to the teaching assistant, and get feedback a week later. And we measured students' learning outcomes using pre-tests and post-tests that assessed their learning of the chemistry concepts that they were supposed to learn from this course. So the results showed that there were no differences for students who had high or moderate spatial skills. So for these students, regardless of what you did, they still learned. But for students with low spatial skills, so students who typically have difficulties in translating 3D to 2D, there we found a difference between the three approaches. So the results showed that students with low spatial skills in the first approach, the drawing approach, had worse learning outcomes than our business as usual control group. But for these students, the second approach, where they were asked to hold up the models against the computer, there the low spatial skills students showed significantly higher learning outcomes. So we think that the drawing approach was worse for these students than the business as usual approach, because drawing on paper first doesn't support students in this task. And if they make a mistake on when they're planning the drawing, then they make the mistake again when they put it into the computer. So basically, they make the same mistake twice before they get any feedback. By contrast, in the Hold Up the Model group, students get help from their partner directly on the task that is difficult for them, which is to translate the 3D into the 2D. And we also think that the reason why the teaching assistants put their bet on the approach that proved less effective for students with low spatial skills is that the teaching assistants are very good at this. They have had a lot of practice in translating 3D to 2D, because that's something you do all the time in chemistry. So for them, it may seem helpful to plan it out on paper first, but that doesn't mean that it helps the students, especially not if they have low spatial skills. So, in this case, we found out that our teaching assistants had what we call an expert blind spot. They think something is helpful where it's not, just because it's easier for them. So this study helped us give better advice to teaching assistants on how to help students collaboratively explain visuals.